Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss the next videos, subscribe to the channel and activate the bell to receive all notifications. Imagine looking up at the night sky. The stars shine motionless in the infinite darkness, yet beyond that apparent calm, a surprising truth is hidden. It is not emptiness that reigns supreme, but a vast, intricate, silent network invisible to the human eye. A network that connects thousands of galaxies in an eternal dance, a cosmic thread that traverses the depths of space and time. It is a structure so immense, so ancient, and so perfectly woven that it challenges logic, established theories, and even our very sense of scale. This network is not an illusion. It truly exists. Scientists have seen it, measured it, studied it. And they have given it a powerful and evocative name, Qipu. Its discovery could mark a turning point in the history of cosmology, forcing us to rethink what we thought we knew about the structure and evolution of the universe. An international team of astronomers and astrophysicists, armed with patience, technology, and intuition, identified this colossal cosmic superstructure through meticulous data collection and analysis across different wavelengths. The structure in question possesses a mass equivalent to about 200 quadrillion solar masses and extends over 1.3 billion light-years. Numbers that escape imagination and seem to belong more to science fiction than science. But what makes this discovery even more astonishing is that Qipu breaks the theoretical limits set by our current cosmological model. According to the predictions of the lambda-CDM model and the cosmological principle of isotropy and homogeneity, no structure in the universe should exceed 1.2 billion light-years. Qipu not only exceeds it, it does so effortlessly. And it is not alone. In recent years, two other cosmic megastructures have emerged that defy every prediction: the giant arc and the Great Rain, both so vast that their mere existence undermines the credibility of the theories describing the universe on a large scale. The name, Qipu, was not chosen by chance. It recalls the extraordinary recording system of the Inca civilization, a series of knotted cords used to transmit information and count resources. Similarly, the cosmic megastructure appears as a tangle of galactic filaments winding through space, like cords connecting and tying the universe into an ancient and complex weaving. To grasp its size, consider that Qipu is 13,000 times larger than the Milky Way and even surpasses the Laniakea supercluster, which itself is a colossus containing over 100,000 galaxies. If Laniakea represents a cosmic metropolis, Qipu is the entire continent. The discovery of Qipu is the result of an ambitious universe mapping project based on the analysis of redshift, that is, the redward shift of light from distant objects, an indicator of their distance. While until recently structures with redshifts below 0.3 were studied, the new project pushed up to 0.6, using data from the German satellite ROSAT, specialized in X-ray observations, along with sophisticated artificial intelligence algorithms to analyze patterns in the distribution of matter. The result? Not just one structure, but 5 cosmic megastructures detected, including the Shapley supercluster, one of the densest in the universe, the vast regions of Serpens, Corona Borealis, Hercules, Sculptor, and Pegasus, and of course, the enigmatic Qipu. These 5 structures alone contain nearly half of the known galactic clusters, 30% of observed galaxies, and about 25% of the estimated matter of the entire observable universe. They occupy an impressive portion of the cosmos, about 13% of the observable space. It is as if we had discovered that, within the universe we see, there are enormous invisible architectures supporting its very structure. But Qipu's impact is not limited to galactic mapping. Its gigantic gravity deforms space-time in such a way that it influences the data of the cosmic microwave background, CMB, the light echo of the Big Bang. According to the Sachs-Wolf effect, Gravitational fluctuations caused by massive structures can alter the path of the CMB, modifying our measurements and leading us to misinterpretations about the very birth of the universe. And there's more. Kipu could also interfere with the measurement of the Hubble constant, the fundamental parameter describing the expansion of the universe. Its gravitational field can deflect the light of distant galaxies, generating gravitational lenses that distort our observations. Some recent models suggest that such structures could indeed form naturally within the framework of the lambda CDM model, as a result of the progressive accretion of matter along cosmic filaments. However, scientific consensus is still far off. Many experts point out that such structures should not be so common, and the fact that we are finding more and more of them casts doubt on the validity of the large-scale uniformity principle. Moreover, these structures are not eternal. Over time, and with the expansion of the universe, the gravitational coherence holding them together could dissipate. The galaxies will move away from each other, and Kipu, like an ancient cosmic memory, will dissolve, leaving only faint traces of its existence. But perhaps what strikes most is the unsettling frequency with which these cosmic anomalies are emerging. In 2021, the giant arc was discovered, a curve of galaxies 3.3 billion light-years long. In 2024, the team led by Alexia Lopez identified the Great Rain, a circular structure composed of galaxies and clusters with a circumference of 4.4 billion light-years. If we could see it in the sky, it would appear as large as 15 full moons lined up. And then there is the enigmatic ring of gamma-ray sources, a structure 5 billion light-years wide, whose origins remain completely mysterious. These discoveries confront us with a fundamental and provocative question. What if the universe is not really as homogeneous as we have always thought? What if, beneath the surface of our elegant and symmetrical theories, a wilder, more irregular, and extraordinary cosmos hides, more than we ever dared to imagine? Perhaps we are at the dawn of a new era in cosmology. An era where our maps are no longer enough, and where the universe invites us, indeed, forces us, to rewrite our understanding of everything.